All right, great. Well, you don't have to take any notes. We will give you the presentation. Actually, I have a QR code. If you got phones, you can join the Discord room and talk smack about me while I present, and then I can look at it later. So, Drew, my assistant down here, has a QR code down there. So if you want, you can pass it around if you have troubles hitting it with your phone. So, quick thing about me, I'm the CEO of Medical Informatics Engineering, and I'm just Doug Horner on LinkedIn. Our headquarters right now is over at on Constitution, and we actually have a data center there. That's a picture of it. But we are moving into the Electric Works downtown. In fact, we have this 5th floor at the Electric Works downtown. And this is an artist rendering of what it'll look like after they finally get all that construction done, which will be exciting with the restaurants and all the other fun stuff they've got going on. And this is actually a shot from our conference room. These windows are enormous. It's ridiculous how big those windows are. But that's the shot of downtown. That's from our rooftop terrace. So that'll be kind of cool. And these are some various drawings of how it's constructed and what it'll look like when it's done, hopefully later this year. And we're basically putting in co-working spaces as well as offices. You know, the co-working spaces will have computers. You bring your laptop in and just plug in and you get multiple monitors and headphones and audio, visual capabilities. We're putting in a laboratory for simulating a medical environment and to device interoperability, as well as a makerspace. We're partnering with several local schools, universities, and whatnot to put a makerspace in there, both a lab and a wet makerspace, as well as robotics and electronics makerspace. So, and then we have the requisite toys that you got to have at a high-tech company, football table, things of that nature. We have a theater that we're putting in there as well. So that should be fun. Oops, that's actually going out to where we're getting them. Okay, so another little fact about me, I have 4 daughters. Sorry, I'm putting it on the resume, the personal stuff. I like to climb. I like to no, but yeah, so I 4 daughters, 2 grandkids, a couple dogs, 2 so yeah, on the personal side. A little bit more about me. I actually came to Purdue Fort Wayne in the early 90s. I started programming in high school. I got hooked on doing Mandelbrot sets and fractals back at a time when all I had was an Atari 800 XL. So I actually built my own network of like 7 or 8 Commodores through the paddle ports, literally through the game ports. I chained them together so I could send different parts of the Mandelbrot set off to different computers to calculate different parts of it. And that's what I did, you know, in high school. And when getting on campus here, there was a professor who was a master in computer science. His name was Dr. Saig, who was also physics, had a PhD in physics, but he taught artificial neural networks, got me engaged with modeling actual biological systems, but also doing artificial neural networks. We collaborated on a project. I wrote a lot of the code to do EKG classification with neural networks. So instead of having a cardiologist sit there and classify each beat and what arrhythmia, we trained a neural network to do that and published some papers on that. And that was kind of exciting to do as an undergraduate. I also did some AI research on PET and CT overlay. These used to be different devices, and we did imaging to overlay PET and CT. But it was during this period that I really started to get into what is medical informatics. You know, not just programming, but you know, how can code help us benefit human health? And you know, everybody should know, hopefully in here, informatics is the study of computational systems, you know, for data storage and information retrieval. And specifically medical informatics is for electronic health records, diagnostic testing, medical scans, and so forth. So that's what the frick is medical informatics. Actually, in doing that, I wrote another paper called the Medical Web Project. Back then, all I wanted to do was I think the whole campus at Purdue was fed on the internet by a 56K circuit. So maybe a little bit faster than a dial-up modem. And this was fairly early in the days of the internet. Most people didn't know what the internet was. Netscape hadn't gone public. But I wrote a paper actually detailing how you would use web technology to connect up healthcare institutions, because information lives all over the place, and do it through the web. And funny story that research that we did with the EKG signals and classification, the company got sold for $20 million, which we didn't participate in because the academic team that I was on said that's for the engineers to do. You know, we want to do research. We don't want to start a company. That seems like a pain in the butt. So after I wrote this paper, I'm like, and then I heard about that. The cardiologist that was on our team wanted to form a company. He still to this day lords it over me that we didn't do that. But so I started a company based off of this paper, and that's actually what MIE, the beginning of MIE. So literally in the early days, it was wires and pliers, going out and purchasing frame relay lines and T1 circuits and whatnot, and going out to all over in Northeast Indiana. And we actually became a competitive local exchange carrier in the state of Indiana, so we could get wholesale pricing on circuits, and literally just going out to doctors' offices and wiring them up. And then once we got them on the network, we had, this was the technology of the day. I pulled this from an old slide that I used back in 1998, saying this is high tech. Look at this BlackBerry and a Palm Pilot. You guys probably don't know what these things are anymore. But the problem we ran into back then was everything was basically on paper. That's like, even though we had this network, I'm actually, most of the doctors that I got on the network, I said, oh yeah, I'll get you on the network, and in between looking at lab results, I can show you your stock portfolio. And that's how most of the doctors originally got on, because I could show them their stock portfolio, because there was no medical information on the network. So because of my background in imaging, one of the first things we developed was high-speed scanning to go into those offices and get that paper out of the filing cabinets. And this is our software. We would retrain the medical record staff to just basically feed it to a scanner. And this software would actually detect blank pages, automatically rotate them to the right orientation. And then you would shred the chart. You put it in a folder and get rid of it. So in the late 90s and early 2000s, this was a big problem, was just getting the information out of paper filing cabinets. And as you see here, one of the things too, you'll see little barcodes go through here in the corner, right where I'm putting my mouse. There's a barcode right there. Every time you printed something from our system, we put a barcode on it. So when it went back to the scanner, the barcode knew which patient it was, what data service it was, what doctor they had seen, all that information. So you didn't have to tell the system what that paper was or who that patient was. So, and that was pretty revolutionary back then. So this is an early screenshot of what that looked like. I mean, this is Fort Wayne Cardiology here in Fort Wayne, Indiana. And you can see it's like a tabs. We made tabs that look like paper charts, so they'd feel at home and comfortable with it. We actually let them label their own tabs, because everybody has a different way they would tab out their paper chart. And it would show you in parentheses how many documents were in that tab. This is a picture of our first 1 terabyte RAID array, which cost me $225,000 for 1 terabyte. That I was told would never go down. And I used to go in and demo it by pulling out one of those sleds of hard drives and then slide it back in. And one day I pulled it out and the whole damn thing went down, and I knocked down all these poor doctors. So I don't do that anymore in our data center. So, and this is that auto forms that I just talked about earlier. One of the interesting things, and I think this is a problem with computers and computer scientists too. I make this joke all the time that if computer scientists built bridges, we'd all have to get like a mechanical engineering degree before we could cross the bridge. Like, inherent in bridge design is like archways that limit the weight of the buses that could go through it. There's a lot of design built in to make sure that if you're using a bridge, you couldn't potentially get the weight on it to break it. But with computer scientists, we tend to write software that is so complex to use that you got to get a computer science degree to use it. And my big philosophy to physicians were, you shouldn't use the computer. You should only look at information in it. You shouldn't enter information in the computer. It just slows you down. I actually had early on, I had a dermatologist who felt like if he could use the computer, he'd be faster. I think I saw 30 patients with him by lunch. He had 60 patients that day he saw. And he said, I think if I could e-prescribe these, I'd go faster. I said, I can't sign you into the computer and switch. He had 4 nurses working with him, handing him pre-printed scripts, and some of the names he would sign on there. I'm like, no, you're going to slow down. I said, let me around the afternoon with your nurses. And so we built a whole system around the physician. We call it the minimally invasive EMR. The physician's not supposed to touch the computer to enter information. That just slows you down. And so this is why we invented this process here, where the nurse may enter all these meds in here, and then the doctor writes what they do, and then that gets scanned into the system. Of course, this doesn't always work. This is an OB flow sheet that usually during the course of a pregnancy, you come back for multiple visits. And if you print something out and you scan it in, you print something out and you scan it in, as you can see, this stuff gets pretty fuzzy and ugly up here, and down here it's nice and crisp. So it doesn't work for everything, but it works for a lot of good stuff. So this is actually I think this was like 2009 or 10. We modernized it. So this is actually running on an iPad. And again, I would tell the doctors, you can come in and look at information, but don't enter information. Don't sit there pointing and clicking information into the EMR. Let other people do that. But this you can see, this was in 2010 because it was an iPad. But you can see as technology moved, as browsers got better, we made it look prettier, rounded edges and so forth. So, And by the way, I'll just show you a quick, I wanted to pop into a quick test system to show you what it looks like today. And I'm going to type one-handed. Just to give you some perspective, this is what our EMR looks like today. And we do a lot of technology. So what's pretty cool about this is it's designed, come on, buddy, there we go. to crunch up and be mobile, right? So like if you're on a phone, you know, you want to be on a phone. If you're on a desktop, you could be on a desktop, right? So responsive design, reactive design is what we're focused on, right? So if I'm here, I'm on a sample patient, I can see all this information, what their meds are, you know, allergies, etc. You know, you can design this as you go on the fly. You can basically move things around. And again, this is all reflexive design here. And then, you know, so I can go into medical records and look at EKG, for example, here. Look at results. I can come in here and do forms, for example. You know, now you don't have to print it out and capture it. You just do it on a tablet and then hit upload, and boom, you've got your results here. You know, there's a form instead. So the other cool thing is, like I said, we don't want people to capture, enter data, you know, slow them down. I had a doctor who said, I think if I type 35 words per minute, I think I want to type. And I said, your transcriptionist types 80 words per minute, and she gets paid $25 an hour. You get paid $400 an hour. Do the math. How fast do you have to type before you can outpace your transcriptionist? So, so in our system, for example, I'm actually demoing it. One of the cool things about us, we always were web-based, is that like I didn't install any software here, but I can come in and do things like if I allow dictation now, I don't know what mic I have, but apparently it's picking me up because I can see this is recording here. So I'm now dictating my smart plan. I want to dictate something for the past medical history. Maybe I want to dictate something here for the linked documents and so forth. And you can see up here these things. I can stop and I can come back and play them. Okay, I can't hear it. Apparently the audio is not coming through, but it should be playing someplace. But anyway, this allows them to go in quickly and dictate and then let somebody else transcribe that work. But you can see I can come over here. If I do want to point and click, I can come in here and go, oh, these are problems the patient has, and then make orders and come in here and choose what orders I want to put in and type, oh, I got to order an A1C. I mean, how could this be faster than just dictating what you want, right? Like, oh boy, this is, we have that capability, but again, having the right person do it is important. And sometimes if you have an executive person like a physician or a CEO or whatnot, you don't want them doing that work. You want that information to be captured and then use this for information that the doctor can look at. So, okay. So, one of the things, we do have a lot of machine learning in our system. If I go to a sample chart, we actually have a 70-man practice in Maui Medical Center. So I just did a single sign on here earlier to get into it. And I have a sample patient here. But what's really cool about our system is if I go to a visit here, just as I showed you earlier, I can come in here and now I have, these are problems that Jennifer Pregnant has. And if I come here and say, she's got diabetes type 1 on her problem list and I'm going to do something about that today, I can click here and you'll notice automatically we're recommending, I can do that order like I just did earlier. I could type the A1C, but notice hemoglobin A1C is already here, or a comprehensive medical panel. So I can actually just click off the items that I want, which would be different than if I do the hypertension and I order here. Notice I'm getting a refer to cardiology. So building, and we didn't, our systems learn what people order and also look at the record and see what else is going on with the patient in order to make recommendations to help them accelerate what they can do in the system. I'm not trying to replace the physician. There's no way we can do that. But what we want to do is make the system smart enough to anticipate what they want to do and bring those choices right to them so they don't have to go hunting and pecking and clicking and things. So, and we have other things too, where like we can read the record and automatically see, hey, there's impaired glucose tolerance here. Do you want to add that to your record? That's on, let's see. Yeah, unconfirmed. Yeah, impaired glucose. So a lab result might have come in. Do you want to add this today? And I can click a button here and boom, now it's part of her record. So, so we've had AI in our system from the very beginning, trying to make things smarter and faster for the Drew, you're gonna have to keep me on time just to make sure. I'm doing well. All right. I told him I had 70 slides. He goes, oh my gosh, there's no way you're getting through all that. So just a little bit here, 15 specialties. We actually got to a point, 15 different specialties like cardiology, OBGYN, neurology, et cetera. We had a time 60% of physicians in Fort Wayne were using our EMR. We were one of the first certified web-based EMRs. At the time, most everybody else was a Windows program, and we were one of the first to do that. And we developed 80 different modules, whether that was laboratory resulting and reporting, dictation, transcription, a PACS system, picture archiving communication, which is the medical imaging you saw earlier in that recording. So there were 80 modules that were developed over probably the first 10 years or so. And this is a little bit about our technology stack. At the top, you have what we consider to be WebChart, our EMR. Nginx is a load balancer, and then a whole bunch of host of services behind it. Node.js, C, C++, Memcache, MySQL, or MariaDB and MySQL on the back end, MongoDB for unstructured data, Prometheus for time series, and other services that we put out here that do a really good job of reporting and displaying that data. So, and then it's hard. The development process is fairly continuous. If you're not familiar with continuous improvement, this is an infinite process, right? You plan something, you build it, you do continuous integration, meaning it automatically builds and deploys out to the infrastructure. You operate it, you get feedback from your users, you then adjust a new plan, you then build, you then integrate, and then you deploy. You want to follow this. The faster you can make this thing go, the faster you can be responsive to the needs of your client. But you need a lot of different tools in order to bring that together. And so being familiar with a lot of those and putting as many of those on your resume that you know what they are, as long as you know, don't put anything on your resume you don't know what it is. Don't just steal a thing. Make sure you know that area well, because if you get quizzed on it, it's foolish. One of the areas I highly recommend in understanding agile development is this actually a free book called Getting Real. And this is some good software to install in your brain about that process that I described and how you write software that your users want to use. Too often people go off and they design the software and they write a design, and then they take 6 months to deploy it, and then they give it to the users and the users hate it. And then you go back and you take 6 months before you can fix it. And more things are going where you just deploy early, deploy often, and get it out there. In 2009, the government got into the business of certifying electronic health records because of ARA. Basically put $27 billion in there and then stipulated, what's interesting is they said it in 2009, but they didn't release the requirements of what an EMR would be and to get certified until 2011. So for 4 years or so, and actually didn't start certifying until 2014. So for those many years, nobody bought an EMR. So much for investment and stimulus, right? $27 billion sat on the sideline. So during that period, actually, we got it. Dow Chemical actually came to us and said, "Hey, we don't care about EMRs, but we want a web-based one, and we're in 7 countries. We'll teach you occupational health. We want to bend the cost curve because if you look, everybody should know this. This is the funny thing. Unfortunately, this is inflation right here, right? So if wireless telephones have gone down, right here's zero. Like essentially, if you bought a car 20 years ago, you're expected to pay about the same amount. But look at this. Poor you guys know this. College and tuition fees are the highest things that have gone up in terms of cost. College textbooks, which I think is weird. Like everything should be online, but college textbooks have gotten more expensive and whatnot. But hospital services and healthcare have been off the roof, right? So a lot of these companies are like, we've got to do something about this. We're going to invest in healthcare for our employees. And so Dow Chemical deployed our EMR in those countries, and then all of a sudden, all these other clients just showed up at our door. So Eli Lilly came next, then Chevron, Lawrence Livermore, Walt Disney, all these companies just showed up, but we didn't even solicit them. They just said, we want what they have. And we started deploying our EMR specifically for large employers that wanted to run their own clinics, but also had an occupational health requirement. Yeah, we're now in 64 countries, 7 languages. Over the past 3 years, we have 80% year-over-year growth. So enterprise health has just taken off like a rocket. So has medical informatics helped healthcare? This is a thorny question, because I would say anytime you introduce a new technology and you go fast, it's going to have some pain. And this is an example. You get a bunch of cars going fast, and then all of a sudden I had one physician who told me we're inventing new ways to kill patients because of the technology and people not knowing where to look, et cetera, right? There are big improvements in terms of getting that information out of the filing cabinets and getting better visibility to it, but with such a wide variety of ways of managing that information, and also somewhat of an insistence to make physicians enter things into the record. Boy, we've done a lot of bad things too. I wish we could hear that. This actually is ZDog MD. It is a hilarious video of him talking about life as a physician, having to basically treat the computer instead of treating patients. And it's a wonderful video. It's hilarious as hell. He ends it with like, we need a new chart. And I think this particular part goes out, they built you a turd doc. So this is how physicians feel. In fact, there's an article in the New Yorker about why doctors hate their computers. Death by 1,000 clicks. Doctors are not happy, triggering new malpractice claims because they're EHR. And actually, there's a nice rant that ZDog does about how they call it physician burnout. And by the way, this burnout video that he made was before COVID. So this literally happened before COVID. Physicians were getting burned out on healthcare and saying, we're done, we don't like it. And then COVID hit, and then that's just added insult to injury. So, but there is hope. I mean, in the same thing, Dr. Mark Bronstein talks about how 60% of the physicians using it feel that it does improve quality, but at what cost? You know, like it slows them down, it makes them see less patients, but they do think that they're better informed when they're talking to patients. So WTF is also what's the future? Where do we go from here? Because what comes next? And the idea is that, this is Arthur C. Clarke, any sufficiently advanced technology is indistinguishable from magic, and that's where we need the technology to go. As an example, this is a technology that we're piloting right now where, as a patient moves throughout the practice, we put a little Bluetooth low energy thing inside the clipboard. And as the patient steps on the scale, the weight automatically goes into the chart and they don't have to re-enter that information. Oddly enough, everybody's manually having to enter these things. The nurses have to enter stuff. It's like, this is so tedious and slows them down. And if they wrote it on a piece of paper, it'd be faster, but it's harder to peck and type. And this is actually I'm going to just quickly go through this to show different, like, for example, nurses can be notified on their phones that the patient's in the waiting room. Okay, come on, bandwidth. Really? Darn it. It's loading slow. Yeah, we'll show that later, but if you're curious, here, for example, this is the scale automatically weighing it in and the vitals popping in automatically. VoIP calls, when a patient calls, it automatically routes it to your phone no matter where you're at, and it shows you the patient's name, for example. So we really want the technology to be an assistant. The technology should serve the user, not the user serving the technology. We actually have a telehealth solution. We had to roll this out right away for COVID, where doctors and patients can communicate online, for example. So that's the future of medical informatics. There's also bioinformatics that's on the horizon, where more and more information now is coming in genetic form, right? So right now, essentially, you can think of DNA as a quaternary code. It's code. DNA is code. There's no, essentially, it's a big computer, and the computer just works on a biochemical basis. So it forms basically machines. All code does is code for specific kinds of proteins or enzymes. And this is a molecule that gets coded from DNA. And there's a little drug right there. And there's a computational simulation. So you can write code to simulate using essentially game programming to go and find the binding pocket of where that drug fits within that enzyme. And this is a wonderful thing that we're able to simulate this and really understand it. I don't know if anybody's ever seen like how DNA copies itself. So the same thing, this is DNA copying itself. Those are basically enzymes copying the DNA out to prepare it for cell division. Actually, this is a fun one. I'll just show this because I like this. This is actually a big mega plate that they did at Stanford, and they put lots of different levels of antibiotics. So this is like 1,000 times antibiotic, and then you basically put bacteria in here, and you can watch them evolve as they go. So that DNA right here, so you can track each mutation that happened in that bacteria to be able to survive in higher concentrations of antibiotic. So that's why we got to stop doing that. There's also now you're seeing programs being written to do sulfate tracking. So this is a fruit fly here that we're able to track. We're able to track every single cell and how they communicate with each other, because cells just copy, and at some point they start becoming different tissues. And what programming has to happen between one cell to the next to get that cell to behave like, okay, you're going to be muscle and I'm going to be bone and I'm going to be, and we're now starting to decode that in bioinformatics. And then this is interesting here. Right now we currently do, this is something called a Cytochrome Pathway. Every drug that you take is metabolized by an enzyme that's coded in your DNA. And one person can take, say, Tylenol 3, and it turns into morphine and kills pain in their body. There's a third of the population where if they take it, they just make expensive urine. They don't have the way to break it down into morphine. And we can look at your DNA and tell whether or not you're able to do that instead of giving you the drug and not knowing. So now we have to load 2 billion base pairs into the medical record and then say and be able to warn you on what you can prescribe or what you can't prescribe. And by the way, a lot of drug interactions are people, if you give them a drug, they may overdose because a small amount of it, there's another enzyme that breaks it down and then puts it into your urine after the molecule's done its job. If you have a mutation in that thing, it will stay in your blood longer than it normally would. So we need our EMRs to look at your genome and help physicians, because there's way too much for anyone to keep in their head. Yeah. So this is actually an interesting talk here. This is a fascinating one where, so if people know what Verilog is, it's a programming language here where you can, how computer chips are designed. So that's Verilog there, and essentially it builds the circuits that you need. What he's doing is he made Verilog actually talk about what are called repressors and promoters within genes. So you can actually repress a gene or promote a gene, and then you can use Verilog to basically build, at the end of this, you build a DNA sample, a loop that you put into bacteria, and you turn the bacteria into a little robot, a little nano machine. Because if it senses some molecule in the environment, it goes through this logic gate and produces another chemical that then produces another chemical that might actually then produce a phospholipid, or sorry, a luciferase or something that actually glows. So you can get a signal out of that. So all these things are coming down the pipe. Disease reversal, injury repair, sulfate tracking, age reversal, tissue engineering, et cetera. You know, we do need like a debugger for life. Like if we could just go and put breakpoints in the code, we'd learn a lot more about how things work. But all this information is going to come at, I mean, already we have way too much information. People have their Apple Watches, and physicians have way too much to look at to try to diagnose you. This here is a GPT-3. And actually we just invested, like, this is $50,000 for one rack unit, to put in for these Tesla cards. And each one of I remember when I was writing my original AI, I think all I could address was 640K of RAM for training. And now each card has, you know, what is it? 32 gig of RAM, and 256 gig in the server. And we're going to stack these servers up. But this actually gives an interesting demonstration of what this does. So this is a medical summary that's, that would be dictated. And then you can ask the system, what's the diagnosis? And it actually produces a diagnosis for you. Or you could say, what is the diagnosis code? And the system automatically gives you the diagnosis code, and that's accurate. I have a link, we can play with it later. Or I can come in here and say, too long, didn't read, and it then gives you a summary of that whole note in a short form. So, you know, right now, if there's a ton of information sitting in the chart, the doctor wants a nice, concise briefing, as if a medical student would give them a briefing, so they don't have to read the whole thing. Just tell me what I need to know. So this is like summarize it in 100 words. You know, so it's different variants of that summary. By the way, this also works for code as well. I showed you here, like summarizing the selfish gene in 100 words. You can also say, do it as if you're Oprah Winfrey, and then it gives you a summary of selfish gene as if you were Oprah Winfrey. So there's some pretty amazing stuff happening. Does everybody know about Copilot? Yeah. So I probably don't need to. If you're, this is actually Copilot, where you do the same thing. That's the exact same technology where you basically, you know, start writing and it finishes what you're doing. Like as you're typing, it automatically auto completes and gives you an implementation based on the name of the function name, or it gives you alternate. Yeah, right here as you're typing this function here, this function gives you alternates. So Copilot's coming. Okay. Quick bit of advice, and then we'll open it up to Q&A. Yeah. I know. One of the things I would say as computer science students is to, you know, get familiar with GitHub. You know if you're not familiar with GitHub, you should absolutely be. And I believe you should be reading more code than you write. Like go out there and look at how other people do things before you write it. I feel like so many times when you're going through school, they're like, you know, they give you a challenge, you're supposed to write the code, right? But in the real world, you're going to spend more of your time reading other people's code and figuring out how to fix it or enhance it or do something like that. And so those skills generally people don't have coming right straight out of school. So you will look much more valuable to an employer if you actually have a history of making pull requests, you know, on other people's code. If I see someone who's got that experience, I'm like, that resume goes to the top of the stack, because that's what they'll have to do in my own company. So I highly, highly recommend that you get active on there, find a project that you like. I'll ask about that here. I may just go in here and spend a little bit more time on that. But by the way, Andrew Brown, or Drew Brown, he's sitting down here. That's his email. Yeah, right. So send an email to him. He can send these slides off to you guys. But at this point, 12 minutes. All right, good. so I open up to any questions. I'll be happy to go anywhere you guys want me to go, or even go home. Yeah. Yeah, that infinite cycle you saw there. So the question was, for everybody else, was on the one where I showed the life cycle development. I stole that slide. These are not ours. These are like all the different tools you would see in this phase of planning. So like we use Google Docs for our planning, and we also have Office, and we also actually I don't think Redmine is on there. Is it on there? No, it's not on there. Maybe Redmine's down here. Because sometimes these tools also, when they straddle a particular area, you might actually find a tool that does both. We use, obviously we're using Docker, we're using NPM, we're using Kubernetes. We do something like Slack. We actually have our own one that we developed. Anymore, like a lot of these tools, these integration tools, Travis CI and Jenkins, we're replacing that with GitHub Actions. Everything's pretty much GitHub Actions anymore. So yeah, no, there's a bingo card here of different technologies, and different companies will use different tools because of the evolution of what they started with. Like a lot of people use Jenkins, for example, but I know more people killing Jenkins than I see people setting up Jenkins, for example. So, but yeah, no, I can tell you this though. You're more valuable if you know why not to use Jenkins versus the other tool. I think one of the big problems is when you're looking at this huge mess of technology, and we see this also with with virtualization. Like, should I virtualize or containerize my application? If I want to automate it, should I use just a bash script to automate it, or use something like Salt or Vagrant or whatnot? So there's a lot of complexity in choosing the right tool for the job, and being familiar with what the pros and cons are of those tools is as important as just learning the one tool, right? So I almost can tell you why I don't use most of the tools that are on here, and I can articulate why I don't use them or why this one's better for us than the other. And that requires me to be, an everyday learner. When some new tool comes out, a lot of people, I don't want to learn a tool. I know the tool I know. We have a whole culture of people who like, okay, let's go look at it. Let's try something. Let's do something with it. Let's fail with it quickly. Okay, no, we either like it or we don't like it. So that creates a lot of churn all the time. There's just a lot of things bubble up and people are testing a lot of things. But there's a nice quote that has saved me a lot of time: fail fast, fail cheap. You're going to fail. Do it as quickly as possible and do it cheaply as possible. Learn something from it. And then again, do the same continuous improvement. And that goes for the tools that you use in that process too. So, yep, good question. Any others? Yeah. Yeah. Oh, all the time. I mean, so the question is about what languages do we use? And have we tried new languages? Like when we first wrote WebChart, it was C and C++. That was everything we did. And frankly, I did enough C++ and object-oriented design to know why I don't think object-oriented design is the panacea that everybody believed it to be. Oh, wow, I see some thumbs down. Believe it or not, 10 years ago, I would have been like booed off the stage because object-oriented design was all the rage. And I could probably speak for a full hour on why I think object-oriented has a lot of problems. But C is where we did it. Now, like Node and Python, we did some Java, and then we realized that was a bad idea. So we've rewritten all the Java. So I can tell you, like, for example, when we first started, there was nothing like Ajax. You could not make a request. So we had to write our own ActiveX control in the browser and then make what was at the time, what would have been just as easy an Ajax request through an ActiveX control through a little thing. And we're constantly killing code in our system and then rewriting it with a new technology. If you get married to your code because you wrote it, you have to be just as happy with killing code as you have to be with writing it. I can tell you, I've spent a week writing 100 lines of code only to find out that I could have done it in 4 lines of code, and then cried a little bit, but was happy to delete the 100 lines of code, because you feel like, and I can tell you right now, the smallest commit wins. Whenever I'm making a change to code, the thing that changes the least lines of code usually is the best. The thing that deletes the most code is even better. So yeah, we're constantly, and you just have to do it. So, whether it's, we do little projects all the time. So I've done ones in Rust recently, and I was all Rust happy for a while. And now I'm like Rust, like, oh, I don't know if I like Rust anymore because it gets so bloated, or, so I am constantly I'm the CEO of the company. I still write code. I would say most of my developers hate my pull requests because I don't follow the style guidelines. So I get told all the time I'm not following the rules. But I still write code probably 4 or 5 times a week. I'm still writing code even, so we're a very technology, company. You're not going to find that everywhere. I mean, a lot of places they want you to, they just want you to do the service and they don't care about the way that the sausage is made. They just want the sausage. A famous quote from one of my board of directors was, Doug, tell me about the baby. Don't tell me about the birth. I don't want to hear about the birth. Like we as developers want to talk about the birth. But he doesn't care about that. He just tell me what it does. I don't want to know how the internals work. So, but the internals are what kills you sometimes. So, yep. Question. The question is about tested driven development. In this phase, in the continuous improvement, this only works if you put good tests in there. We have 14 million lines of code in our repository today. Our test environment takes to run our tests, it takes about 4 days to run the tests. Every commit you make, it kicks off a job in the background, and we have a cluster of servers that go through and take every single test. And we have a thing called Selenium, and we invented our own language called Okra. And Okra is a human readable language. We actually our implementers write scripts like do this, then do this in English, and then we actually parse the English and turn it into the Python commands to drive the Selenium. And so that way, because developers suck at writing tests. I'll just be honest, most developers don't do a good job because they think their stuff is, perfect. Why would I need to test it? So we do have just like in security, we have a red team that tries to break the code. On the testing side, we have people who run the tests and our implementers do it. And so as soon as a bug happens, when you're doing a bug fix, a test has to go with it. If we had a bug reported by somebody, guess what? Now there's a new test in the test cycle. One of the big problems with the test cycle is like, when does the test ever go away? People start to get afraid of deleting a test, especially irrelevant ones that aren't necessary anymore. So, but you do need, if you're going to go rapid cycle, you want to have, because I actually had a developer once who felt so anxious about his code going out, he couldn't deal with it. He had to leave because he was worried about, killing a patient or impacting patient care, that made him so anxious. He just didn't want to do it in healthcare. And testing gives you more confidence in that. So, and I can tell you, I've been in the position where we didn't have good testing and stuff slips through, and then you're getting a call at 2 a.m. because 2 a.m. here is still, noon in Indonesia. When you're in every damn time zone on the planet, you're going to have to wake up and fix that problem. So a lot of you just have to have a couple developers get that 2 a.m. call, have to get out of bed and fix the problem before they start realizing the value of test-driven design. So good question. Any other questions? Yeah, sure. Yeah, so it's funny that the I can't type it. Oh, I'm not even in the field. And I want to dictate it. I can't hit I want somebody else's. So the Amazon got started. It's a funny story. So AWS got started because they built a data center for themselves, but Amazon has this philosophy that if you're going to do something for yourself, you should engineer it to then be sold as a service to other people, and then we'll just be your largest customer. And we've done that same thing. So our data center hosting options. So we do something very similar where we have different options in our data center that you can choose from. Oh, this is not the one I was looking for. This is somebody's simplification of it. But yeah, so we run our data center like it's a separate company, and we do host other people's things, but because I do like that philosophy that every department within a company has to operate like a company and compete for other departments' resources. So we sort of operate our divisions like that. Our help desk, for example, serves the rest of the company, and they're judged on their performance based on evaluations from the rest of the company. Too often in companies, like once you're on the inside, people stop caring about you. So we try to set up our company so that everybody knows who their customer is. And the data center's customer is those different companies that I have at the bottom of my slide. And by the way, if they don't do well, then we start hosting in the cloud. But it actually works out really well. We do a decent amount of hosting of our own stuff. We do have some things in the cloud, and we do have some clients that host it on their own data centers. So we have to be able to orchestrate our whole environment and stand it up in Amazon, or stand it up in our own data center, or stand it up, within Disney's data center run by Xerox, for example. So no, go ahead. Nobody else is raising their hand, so and we're good. So yeah. Yeah, it's very interesting because cloud. Everybody thinks that cloud is a pan. You like actually draw the cloud, and the magic happens here, and you put it in the cloud, and somebody else worries about it. It doesn't work that well. You gotta worry about those details. Um, you know, one of the things that I wish more people understood is the boot process of a computer and understand PXE booting and then boot chain loading and understanding how servers get stood up, because you can do that. You can automate the entire boot process in physical hardware just like you can in virtual hardware. And we kind of invented our own. It's all using the same technology. Where I'll get a little technical here, but in Linux, if you're gonna DHCP boot a server, and we're gonna know what MAC address it is, so we know what it needs to be when it grows up. We know what network segment it's on. Oh, you're gonna be a web server. Okay, let's get this kickstart going for the this kickstart config for the Linux build, and then the Linux environment stands up. And then sometimes those environments stand up and they're just bare metal and they run our services. Sometimes those servers stand up and then they're basically a Kubernetes like. We don't actually use Kubernetes in our own data center, but we use something like it to host containers and then run virtualized, or we use a virtualization called Proxmox instead of Citrix or things like that. So, but it stands up a Proxmox environment and then says, okay, I'm ready now. I can DHCP my other things that I need to put up in those environments too. So, but yeah, we orchestrate the hardware at the lowest level, which is a lot harder than it should be. I think personally, it's not the easiest thing to do, and there's a lot of different technologies you got to be familiar with in order to pull it off. Whereas if you do it virtually, it's sort of like all that mess is taken care of. But thank you. Yeah, when you virtualize, so like for me, I'm buying the hardware and hosting it, and if I have 50 servers, but I have 25% overhead for virtualization, 15 to 25 depending on optimization and stuff like that. Well, that's more hardware I got to buy. So some services are perfect for virtualization when they're not going to use very much of that server. But when we're hosting, we have probably there are times where we have 500,000 people hitting our data center. I need all that metal working. I don't want it like spending its time context switching because I want it working on those requests. So and everyone says, oh, but you can scale by adding more virtualization. Well, yeah, you do sort of, but I'd rather have it sitting there ready to go instead of letting everybody sit there lagging, waiting for the stampede. Oh, there goes battery. We actually went live with Northwell Health, which is one of the largest healthcare systems in the country. With because of that, we were the first vaccines in the country. Northwell in New York, there was 2 doctors who got the first vaccines. They use our EMR to do the medical surveillance, and then they sent out an email to the whole staff, everybody everywhere, going, okay, sign up for your vaccines. And they didn't use our system because we try to load balance it. We try to send out emails only as fast as we can actually get people to come to the site. And you would have thought we actually had, like, I don't know, tickets to Taylor Swift or something. Our systems would just get swamped by people trying to schedule their vaccines. So what, you're not a Swiftie, or yeah, I'm just saying, come on, Taylor Swift, come on. So Drew likes to make fun of me. So, but sometimes you can't handle the load and you got to defer it off. We have a waiting room function now where it's like, if the servers are too busy, they send you over to another place saying, okay, you got a ticket, you got to wait. You're number 70th in line and it's going to take you 2 minutes and stuff like that. It was an interesting experience going through COVID, and COVID actually worked. I mean, COVID's horrible, but there's an amazing legacy that's going to leave within healthcare, like virtual visits, being able to see your doctor. I don't think we would have seen that had we not had COVID. The vaccine, just to be, I think we're going to have vaccines against cancer here not too long in the near future. So, COVID, what doesn't kill you makes you stronger, and I think we'll be stronger for it. But boy, I don't want another 2 years of that nightmare ever again. But so, all right, I'll keep going as long as you guys want to go. So I have a 4 o'clock, but yeah. Gherkin. Yep. Nope. Actually, Gherkin. So Okra's based off of Gherkin. Yeah, we read Gherkin too. So again, I'm very familiar with Gherkin. We used Gherkin for a bit, and the problem with Gherkin, because you have there's like a statement, there's a sort of formality to the way Gherkin, like what's its purpose. You have to say its purpose before you do the test, like why you're writing the test. Yeah. It's kind of designed after the principle of having a user story, so you know what that is. Yeah. None of our implementers ever wanted to do that. Like they, like the people who want to use the system just want to get right into it. Like, click, and they wanted to write it like click on, and they want to write it like you would tell another person to do it. Like, enter your username, enter your password, enter your man, I wish I had two hands. I would just demo it. But because we have it as an open source, I think called Herbie that actually runs the language, but it looks natural, like how a human would speak. And it just basically recognizes verbs and nouns, and the nouns then turn into things that are sought into the page. So if you say, type your username into the username field, it looks for a field named username and then types that, like type Horner into username. And I could say it 4 or 5 different ways, and it still sort of figures it out. But it actually tries multiple ways. Let's find a input with a label for it, because if it's web accessible, for handicap, then that's beautiful. Like my developers, when they do it and they write it correctly, then it's very easy to navigate the page for a test thing. When it gets really tricky is when they're like, oh, okay, I have to use an XPath to find out where this damn thing is inside the DOM and all of it, and that's the input I want you to type in. I'm like, no, don't do that. Go put a label on that. When I see a test written like enter the age of the patient into //roots form 3 / I'm like, oh guys, go put a label on that damn thing. So, and we have a team that now thumps people when they do that. They just want to get the test done so they can get it deployed. So they don't want to fix the fact that it's missing a accessibility element. So it was out of using Gherkin, I think, that we actually said we could do better. So when we invent new software, to get to the root of your question, we try to make sure that there isn't something out there already. And the problem is that we tend to be a little bit early to the game sometimes, and there isn't something there. And so we end up writing it. And then somebody eventually, like I talked about with ActiveX and having to write my own Ajax. We spent months and months, really kind of developing that technology so we could do autocompletes. Like we couldn't do autocompletes until we had that. And we had an ActiveX control we'd load in the browser, and we thought it was a competitive advantage. Like, how did you make your browser do that? And then when Ajax came out, we poured out some beer and said goodbye to this thing we didn't need anymore. And it was probably more than a year worth of development. So we write, we're a bunch of developers, so there's always a debate on build versus buy on everything we do. Like, we have a ticketing system, Redmine, that we use for ticketing. And right now there's a big debate as to whether or not we should write our own ticketing system or go get another one like ClickUp or something like that. So that debate rages and you just have to do the cost benefit analysis. And sometimes you get cheap interns or newbies, and you go, here, go burn a year on this little project, and we'll see where we land. And as long as you got to be okay with failing. And we sometimes place our bets. Okay, we're going to do Gherkin and we're going to do this, and then if this is better, we'll switch all of our chips over here. So, but yeah, I have been told multiple times that it is by people who just want to buy a product. Why do we have to build it? So, yeah. Oh, absolutely. Yeah, you can go to MIE web and see it. Some of it's open source already. So, for example, this is one that's hilarious as an example. This is an old example. Actually, I think, yeah. So, Alternative is a free Tiff viewer that lets you view Tiff images inside the browser. So, Tiff is fax. That's how everybody does fax. We wrote this ActiveX control that basically lets you see Tiff images in a browser. And we released it for free on the internet so everybody could download it. And companies kept saying, well, we can't install free software. We got to pay a license for it. And we said, okay, sure, $5 a user, or maybe it was $1 a user or something. Just to have a license of it and to have a bundled package. Because we also made you register it when you made you enter the first time it loaded. Who are you? Because we want to know who you are. So, okay, well, for whatever, we'll give you a version. You don't need a license. I think we probably done something like $3 million in sales on that thing that we just gave away for free. They could have got it for free. So yes, we do that often. That's part why I have all those logos at the bottom for all the different companies. I usually make a company that serves a client. Like a company needs to know who its customer is and then be viciously on their side in serving that. And I'll set teams up who serve a customer or client and go after that. I'm more of a company should be organized around a product or a service than a product should be, because I feel like a company, if you organize it, they can get whatever resources they need, whether they get it from the parent company or they get it from outside, they should be allowed to grow. And I would really love more entrepreneurism to be taught in schools, because I think we're in the gig economy anyway. I think everybody's got to be prepared with, oh, by the way, one of the other things I just remembered, go make a profile on Upwork and do work. If you don't have a job, go make a profile on Upwork and go try to get work there. You can get paid to do work. And that gives you experience of understanding, how to look at somebody's proposal, how to respond to the requirements, how to then get the job and then work it. And it'll probably be a disaster 4 or 5 times, but it's good to have that disaster. So I hope my answer was in there somewhere. Any other questions? Yeah. Yeah, it's always evolving, right? And there's always a bunch of tools. The question was, how do you stay current on technologies that evolve? I have a phrase I use all the time. You got to kiss a lot of frogs to find a prince, but you got to kiss those frogs. And so I mean, my company is made up of some people who just want to come in, just do their job. And by the way, I'm an attention deficit disorder person. I can't work unless I got 10 things. I did this PowerPoint here last night for the presentation today, but I was also closing tickets, responding to emails. Like I was doing 4 things at the same time, wherever my mind darts. And I surround myself by people who can take all the crazy stuff I do, who want to work on that one thing and then deliver it and get it to conclusion. So it takes a mixture of people to succeed. And you got to know what it is that you want to do, what your tastes are, what you like to do. And so I have certain people that actually go out and they're my taste testers. They're my frog kissers. They like to kiss frogs. And then I like them to come back and share what, and there's tension between the people who don't want to change, who want to do what they want to do, and those that want to change every day. But I try to cultivate a good mix of that so we can stay on top of it. And the tools that there's a bunch of YouTube channels that I subscribe to. Reddit's, one of my other guys, he just lives on several Reddit channels. I'm not a big reader, so I have, unfortunately, I'm subscribed to some ridiculous number of YouTube channels, but I prefer YouTube, and I watch all my YouTube videos at 2x speed. So I don't know if that's crazy or what, but I can't anymore. Like we have this culture at MIE where every quarter you have an objective you meet, and then everyone has to do a 5 to 10 minute presentation, and they make a presentation on what they've done in that quarter, which I think is a good skill to be able to say, here's what I've accomplished, and here's the lessons learned. Here's the things that I would say I wouldn't do again. And here's the things I do. And then here's my objectives for the next quarter. We used to do all those interactively, and I got so bored. I'm like, okay, everybody videotape it, because I just want to watch it at 2x speed. But that actually turned out to be very valuable, because then everybody gets to watch it. Like all the videos are then available to all the other parts, and it's a good way to stay on top of things. So like I said earlier, reading more than you actually write. I would say if you want to stay on top and you really feel like you need to be, and I will tell you this, like, I remember when I was on the internet, and I actually wrote code to find every new web page that got stuck up. Every time there's a new, I got to know about that new web page, and I wrote code to scan the web page when I was at Purdue down at West Lafayette. And then the military showed up and shut my server down because I stumbled into some military zones, and so that was fun. But I had to know every single thing, and over time I've worn out, and I don't need to know everything, but because I've kissed a lot of frogs, I can recognize that if it looks like a frog or it doesn't. I will say this: when you're in GitHub, so getting to know. Let's do this. We'll just do one of these. Oh yeah, good point. Yeah, but getting to know how to read a GitHub repository, like if you go in here, I just picking one at random that I happen to know, it just popped into my head. But like, how many tags have they done? How many branches do they have? How many commits do they have? Going to the Insight tab, looking at the insights of what's going on. Who are the contributors? Like look at the contributors, look at the commit history, look at who did all the work. So Benjamin's not doing work anymore. Benjamin and Glass are off the project. So who's doing work now? I could come in here and see, okay, so Storyteller Z is doing more of the work. What does he do? Who does he work for? Okay, yeah, he's Storyteller Z. He's in Europe. Let's see what other contributions he's made to other projects. Oh, look at that. He's working on all these other projects. It was a pretty hot day there. Let me go look at the things he's working on that day. Getting to know how to navigate GitHub will tell you a lot. That's just understanding, is this an up and coming product? Is this an up and coming technology? Why did the 2 founders leave the project? What's going on? I ask those questions of big projects before I get married to them, and whether or not I want to take them on. Because I can tell you, I've used a lot of open source in in my technology, and there are more than a dozen or so where I've actually inherited. Now we got to maintain the damn thing because the original authors are off doing something else. So yeah, reading a lot is useful. So, oh, I thought that was a question up there. Dr. Kim, did you? Yeah. So let me reflect the question back. And it's interesting because you said medical. I don't know. I would give, I think the question was, what do we think is needed in the medical field and how to be an entrepreneur to go after it? Is that your question? In what? Oh, health informatics. Right. Yeah. Yeah. Health in general. So that's one of the reasons I'm investing in this Electric Works project, and I'm actually building another. It's a not-for-profit called Bioinformatics. I met with the biology department this morning over here, and I've met with Indiana Tech as well as Fort Wayne Community Schools to introduce some of the stuff I touched on briefly on bioinformatics and health informatics, et cetera. Because I would like to see. I mean, a lot of that goes to Indianapolis today. Indiana's big on Indiana in general is seen as a leader in healthcare. But Indianapolis is the center of that universe. But I think that is the future, right? I think health technology and technology in general, as it impacts health, as we try to reverse disease, increase lifespan. One of the areas I'm interested in, I'll give you an example. One of the areas I'm interested in is how do cells communicate with each other to die. Like what happens, like for example, when someone gets shot, they bleed out and then their brain dies, right? And it happens all in 4 minutes. For Christ's sake, 4 minutes. We could back up our servers, but if you get shot, you're going to die in under 4 minutes or stroke out. It turns out your brain does this. It's a suicide. Like one cell, when it gets low on oxygen, tells other cells to die in a programmed cell death. And you actually have, there's literally messages telling cells to commit suicide. And it looks like, some of the theories on this is it looks like it's an attempt to save the lower brainstem. Your higher order functions shut down in order to save and conserve oxygen, because as a species, all you need to do is walk around and be able to pass on your genes. You don't need to think and have dreams and have families and love people in order to actually pass on your genes. That's one of the theories, right? But there are frogs that, go get frozen and they stop their neurons. Their neurons don't commit suicide. They get frozen. They can come back to life. Wouldn't it be cool if you could just give somebody a drug that would interfere with their programmed cell death and then do a 45-minute surgery and they didn't die or come out with any brain death? There's a lot of by the way, there's a lot of reasons why that can't work, and because of the speed of the action potential and the way the mitochondria are sucking up energy, and basically it's like trying to keep a balloon full. And if you can't keep that balloon full, it'll collapse and then the cell falls apart and it creates other damages. So it's not as easy. I just said it. It's a very complicated thing to do. But that's an area I'm interested in. Obviously, there's other people are interested in, like, okay, I just watched a thing on PBS last weekend about artificial limbs. There's a climber at MIT who's, basically putting limbs that are sensing muscle movements and moving your foot and articulating it like it's a real foot. And he actually climbs mountains now. And in fact, they're talking about the fact that his limbs are giving him a competitive advantage. Now, like you almost want to get, there was somebody who was competing and says, I think I want to get my legs cut off so I can compete with him. So there, that interface between biology and computation. Elon Musk, for example, has invested in Neuralink, and they're doing some amazing things with being able to attach things and be able to restore vision. So getting silicon and carbon to work together. Carbon being we're carbon based, and the computers are silicon based, making that into a synergy. As soon as they get that vision capability, like the Matrix, I'm going to jack in because I want to be able to think of something in Google and then see it in my mind's eye and do the Google search without having to with one hand and type the damn thing. So once it's safe, I'm signing up for it. Yeah. So there are definitely opportunities that are there for that brain to human interface. It's one of the things that's interesting is everybody thinks they have a body. And that they don't see that over time that all their cells are being replaced. Like every cell that you have, you're more like an anthill than you are like a rock. That every cell in your body is just a little robot that's running a program, and most of them are programmed to die. And part of that is because of parasites and viruses and things of this nature. In other words, the reason they die is because that acts as a barrier to a virus taking it over. So most things are programmed to die, and if some viruses reverse that, which is why you have HPV that causes cancer, because they are able to go in there and say, hey, we're going to overtake the cell, we're going to take the machinery, we're going to copy ourselves, and we're also going to make sure it's immortal and it won't ever die. And they have instructions to do what's called something called telomerase that adds on to the DNA to allow it to continually copy forever and ever and ever. But we're just now starting to learn this stuff, and there's a whole panoplia of technology, I think, both from a computer perspective in computationally understanding what's the consequences of injecting this mRNA vaccine, where is it going to go in the body, which receptors is it going to bind to effectively. That's just a pure software thing, understanding the binding pockets for where that mRNA would go and duplicate. So I don't know, hopefully it gives you a wide variety. Now, as far as commercializing that technology, some of this is like, a lot, you never know which one's going to be successful. It's just about keeping going after it and finding something that's useful and that people are willing to pay for, and being persistent. I go to workouts. It's funny. My wife and I are cut from different cloth. I'm an entrepreneur because every time we go to the gym, I look forward to the workout, and she hates it. She hates going to the workout because she remembers the workout yesterday and she was miserable. I look forward to it. Then I get in the workout and I'm like, now I'm miserable. What the hell did I do? I have this like short-term memory for the misery. And I always bite off more than I can chew. And then I ask, why the hell did I did that? But then I look at the next challenge and I do it again. I think that's, if you're wired like that you always want to bite off more than you chew, and then you reach for that thing, and then you go, okay, I'm going to do that again. That damn near killed me, but I'm still here. I'm going to do it again. Then you're an entrepreneur. If you're more of the person who remembers the misery and you don't do that again, you're probably one that you tuck yourself in behind an entrepreneur who finds somebody, you either find something you want to do, and you make it your mission to serve other people, and you do fun, and money will come. And if you don't have that, then find somebody that you respect, that you can follow, and try to catch their dream and work for it. But that's my only advice is I think, and the interesting thing, there's a lot of money chasing this stuff. Like getting money right now for an idea is not very hard because there's so much money circulating around, and investors want to put their money to work. So, but I could tell you, like, somebody posed, like, Doug, would you do a business again? Having known everything you were going to go through. Like in 2015, we had a data breach that was one of the larger data breaches that we had in our country. We're still in, I think, the top 12 or something in healthcare. We had like 4.9 million records that were lifted by a Russian hacker who pulled that out. It could have been 70 million, but thank God some of our safeguards worked. Boy, that about killed me. Like, I do not want to go through that again. And we had to put like 50 or 60 other measures in place. And but that's one of the big problems with information management now, is there's more of the information's out there, and it used to be considered an asset. Now it's basically a liability. I don't want personal information if I can avoid it, because now I got to notify everybody if somebody gets that information who shouldn't have had it. So that's a danger to it. But yeah, having to learn how to run a company, how to learn how to do taxes, how to learn how to, hire and fire people, all that, like, you got to be somebody who wants to do lifelong learning, not just in technology, but how to interact with people, how to lead them, and so forth. And watching other people do it and then mimicking what they do is what I'd recommend, or finding out, or part is the best. I can tell you, I can't do what I wouldn't be successful wasn't the team of people that I have around me, that we all have each other's backs. So finding a good group of people that have different opinions and different skills, because you don't want a monoculture. You don't want everybody being the geek in the back room. I've got people that work for me who like just want to get the bill out. Like they just want to send invoices. They don't want to think about all the other things I want to think about. They want to send an invoice. And other people find them to be, those are Luddites. They don't want to get on board. Like, but those Luddites are paying the bills. They're making sure you have a paycheck. So, having that variety of people around you and partnering up with them, that's the main trick to succeeding, because you can't do it all by yourself. Everybody's like, don't ask another question. Damn it. We got to get the hell out of here. All right, good. I wore you out. So yeah, if you think of anything later, you got Drew's email. He can help get connected, and good luck to all you. I want to see more Fort Wayne people taking over the world. So thank you. Somebody might drop this.